We went on the USS Turbulence as part of a study to try and measure turbulence associated with a destroyer and ultimately how that turbulence would affect a laser placed on the ship as a weapon. The turbulence we're talking about isn't necessarily large-scale wind like you think, but actually very small-scale and a micro-turbulence that exists.
Turbulence causes these tiny fluctuations in the density of the atmosphere that stand between the source, the telescope, and the target. And so what happens is when we propagate through that with our laser beam, that causes the beam to wander and defocus. So by the time the spot hits our target, the spot size is now much larger and is no longer sharply focused.
We're trying to look at different variables and then characterize the turbulence based off that. So we're measuring things like temperature, solar irradiance, and seawater temperature.
So this is one of the key measuring devices that we used on the ship. And the way it works is that it sends ultrasound pulses across this source right here and the receiver over there, 3 of them across here. And when it sends that ultrasound pulse, it can measure the speed of sound. And then based on that speed of sound, we can determine what the temperature is.
A big part of the project was to figure out how to both securely attach the equipment.
So Lieutenant Busby came up with some really good ideas for how to bolt these down with chains and so forth so that we could make sure that we had a good secure connection. It wasn't going to blow over and as we're going out to sea.
And then also figuring out how we can run this equipment off batteries because we didn't want to have to connect anything to the ship and open up any deck fittings that would allow water in. So it needed to be completely water resistant and self-contained.
We got many gigabytes worth of data and we've already made some preliminary analysis and seen some very interesting effects, some things that surprised us actually that we're still trying to it's going to take a while to work through that and be part of Lieutenant Busby's thesis and maybe even some follow-on students' theses to really analyze all this data.
What we would really like to get from this is to try to understand why we saw the turbulence that we saw from the other measurements that we took. So again, the ultimate goal, I think, from the perspective of the warfighter, is what is that laser weapon going to do when you push the button to fire it? And so if we can use the information that could be easily collected aboard the ship to predict what the turbulence is going to be and then project from that what the performance of the laser weapon will be, that's the ultimate goal, I think, of this project.
There's several benefits to a laser weapon system over a kinetic weapon system. Time of flight is huge. The laser is going to propagate out at the speed of light. You don't have to wait like you would for a missile or a round fired from a gun to get to the target.
One of the big problems with conventional weapons is if you got a threat coming at you like a cruise missile, let's say, that's coming in at Mach 3 and you're trying to fire another missile at it, well, you're basically shooting a bullet with a bullet and they might meet halfway through, but then if you destroy the target when it's in close to the ship, then all the shrapnel is going to hit the ship. Whereas with the laser, you can engage it almost instantly out where you first detect it, then you can destroy it when it's far away from the ship. That's the goal.
The unique position that NPS holds in this kind of research. So we have, of course, laser experts here. We have meteorology experts here. And we also have our students who are naval officers that are here. And we need all 3 of them for this kind of project. So Professor Blau and myself, we understand the laser physics and how turbulence affects a laser beam. But there's no way we were going to be able to get on a ship and install the equipment and secure it and live aboard that ship for a few days without the experience and help of Lieutenant Busby here. So it really takes that operational experience that tie the science and to the application.
I think that's kind of one of the benefits of NPS is you've got people that are experts in many different fields, but we're all here on the same campus and we can all kind of ping on each other to make these very advanced, difficult projects happen.